So, hello everyone. Welcome to this week's episode of ClueCon Weekly. This week joining us is Sagar Malam from Ecosmob, Senior Project Manager. Thank you for joining us today.
Thank you so much, Luca. It's totally my pleasure, and thank you for the introduction. This is second time I'm
Yep.
featuring in ClueCon Weekly, and I would like to thank you again for having me here. So it's really pleasure and fun to talk with you, really.
It's always fun to chat with you and the people from Ecosmob. We've become friends over the years because we've done
Yeah,
a lot of episodes together. And in fact, we had an episode a couple weeks ago where we discussed some of the known technical aspects of what Ecosmob was doing, the products, the projects, etc. I know you work in the UCAS field like I do, so there's a lot of architecture there. So maybe we could be a little bit more technical this time around and just look at the nitty gritty details of what you've been doing, which is always interesting for developers and systems people.
yeah, yeah. So you are right. Like mainly, I have experience with UCAS and I have worked with designing the architecture of full-fledged UCAS platform.
Nice.
And so far, we were only focusing on features, like from the user experience perspective, what should be the best way to design anything. So that was something that we were working on last year, and like in
Hmm.
this year, we have started to focus to make that whole architecture elastic, so we can scale it easily. So initially, like we used to use only something like free switch, OpenShips, MySQL database in order to implement the services. But now, like we are adding some more components in that architecture, like introduced RabbitMQ, Kafka as a message brokers, and NoSQL to scale it bigger. And also we have explored a lot in Kubernetes and Docker, so we can do the orchestration and kind of uh, make server management maintenance very easy.
Yeah.
And I would like to share my experience with Kubernetes, especially like a lot of people in the web domain, they are a bit afraid of using Kubernetes.
Oh yeah, they
Like,
are. So I was actually about to ask. I mean, the two things I'd like you to really go in detail about is Kubernetes first of all, and why is it not as hard as people think, etc. The other thing is really work queues like Rabbit, Kafka, etc. Because that's another tool that is very underutilized in our industry. People, instead of just using Kafka, Rabbit, people come up with their own weird work queues based on complicated stuff that and they'd have to debug them. So those are the two things. But let's start from Kubernetes. Like what led you to going towards Kubernetes first of all?
yeah, so in nutshell, like it is a trade-off. So obviously, like Kubernetes works on top of the virtual machines, and obviously there will be some overhead. But at the end of the day, it is a trade-off. What do you want? Like, can you survive with little performance bottleneck or overhead, or you can survive with spending a lot of time in maintaining those servers. Like imagine in those earlier days, like if you have to do some kind of maintenance, it was so much painful, but Kubernetes solves that problem. It saves a lot of time and money with the maintenance, because most of the things it automates. And also, if you want to scale, like it is very easy to scale with Kubernetes. So for me, it was kind of trade off. Like I can live with little issues with the performance, but on the other side, I'm getting like very good way to maintain my infrastructure and automate lot of things. So usually I would get certain amount of calls or traffic within a particular virtual machine, which would have certain amount of CPU and RAM. With Kubernetes, like I'm not able to get same amount of traffic, but on the other side, the lot of cost is saved in terms of like maintaining the whole infrastructure. And personally, from my experience, I have not seen too much difference in the performance. Like there are some uh, performance issues with the network, but otherwise everything else works just very well with Kubernetes. So that was, I think, the fantastic addition in our technology stack. And like moving forward, we are we are recommending that to our customers, and we ourselves are also using Kubernetes because it is like if you want to stay in the competition and if you want to
Mhm.
grow faster, you need to use something like that. Otherwise, you will like spend a lot of time in doing maintenance, and
Oh
you will
yeah,
not get
that's
chance
true.
to do other
Another
things. So,
thing, another recommendation I've made recently, and we were discussing this just days ago with the customer. Uh, Being able to have Kubernetes in your stack, and leveraging containerization and all the various services correctly allows you to even develop the applications differently because you don't
yeah.
have to care about a lot of things, so you can focus on fixing the actual problem instead of spending mm, weeks just figuring out the server, which is the same thing with Kafka. And really, it's for example, if you're running something like serverless, so you want to be able to deploy, an IVR. I want to have some logic in my IVR. Every customer has a different IVR logic, so we want them to be able to deploy a little bit of code and just does the magic without having to run a server themselves, a web application, and whatnot. And if you do it with something like Kubernetes, it's almost too easy. Like it's a
Yeah, yeah,
it.
too easy, too easy. So I think for me it is now no brainer after the experience that I have with Kubernetes. So I would like to recommend everyone like start using it. Don't be afraid of it.
Are you running a full Kubernetes distribution, or are you running one of the tools that are on top, like K3s and all of the other? You're using
K3,
stock
yeah,
Kubernetes.
yeah,
Oh,
K3.
good. Okay, Tres. Yeah, that's what was recommended to me too. I've been playing around with it. It's great. Do you use any UIs or management tools? There's a lot. Uh,
Yeah, so I have some experience with Argo CD,
mhm,
which is like a very good tool according to me. But still, I'm still in very early stage. Like most of the time, we have used command line to
mhm,
like do a lot of things. But now I'm thinking of adapting GUI. There are a lot of options available. Argo CD was one thing that I have adopted as of now, and so far it looks good. But still, I'm going to like do some more research and see. But yeah,
yes.
Argo CD for now
Oh,
for
cool.
that.
So
And
I'll try that. I'm looking for something, so I'll try that too. Plus, it's all open source, which is great. Really, it's it's the
yeah,
beauty
yeah,
of open source, right? It's just what
right,
we
right.
what we needed.
And also, like one more thing that I like about Kubernetes is stateful sets.
Mm,
Like it can help you like manage whole cluster, and
mm,
I found it very very useful with deploying RabbitMQ cluster. Like the stateful set is aware of what application is doing. It is not totally agnostic to whatever is running within the pods, so it gives you kind of control in order to like act differently whenever something goes
mm.
wrong with the application. And also there is some kind of special requirements required by particular applications. Like for example, in case of RabbitMQ, like whenever a pod stops and starts, it should not like change its host name. By default, Kubernetes would uh, put some random string at the end, and that used to break the cluster every time.
Mm. Oh,
So
okay.
every time you stop and start, it would just break down the cluster. So like the stateful set, something that I learned about, that was very interesting, and it was very helpful. Like it makes Kubernetes like aware of the limitations of the applications, and we can do a lot of things with that, and like implementing the cluster, maintaining it becomes very simple. And also like it gives a lot of options to do like plant maintenance. You can just tell it that okay, on like just bring down two nodes at a time, and let everything else run, and it will take care of networking stuff and everything. So
Wow.
um, I think
Yeah,
all of that is very very interesting. And
I'll be honest, I hadn't heard about stateful set yet. And it's kind of like Docker Compose, but more powerful from what I see. You can specify ordering, you can specify all sort of relationships between containers, and it solves a problem I had. So thank you for pointing it out. It solves a problem I had in my testing, which is pods don't have a name of sort, right? So when you start a process in Kubernetes, it's just there. It will do its thing, but then if you want to keep that pod around and you want to update, it will just destroy that and create another. So if you have something relying on that pod existing, you can fix it. You can do a lot of scripting to fix it. There's deployments, which is what's using, but stateful set really allows you to define that this container needs to stay here and it needs to have this name and these resources. And when it gets restarted, you get another that's the same place, same name, same resources.
Exactly.
That's great. Yeah,
Exactly.
that's
Yeah. So
really super interesting. So I'll ask, since you're Kubernetes sort of an expert, I'll
no, I'm still a beginner, but yeah, like these days it's
well,
very easy to research and learn through
you've done a
internet.
lot of work on that. So say I am running something like, well, let's use the usual example. I have a FreeSwitch application that I'm running. Let's say I'm already on virtual machines. That's when people are running on bare metal servers in their offices. They have other problems, but normal people are on a VM already. So I have a FreeSwitch server. I have a web application that serves dial plans to that FreeSwitch and some UI, usual stuff, right? And to find
Mhm.
that Sagar is number 101 and Luca's number 102. And when Luca dials 101, it has to call Sagar. Nothing complicated. But then how do you start looking at migrating to Kubernetes there? Like, what are the steps?
Yeah, so like first thing that you should do is like if you are using a virtual machine, you should create. You should first adapt Docker. So no Kubernetes, nothing. Simply convert your application into Docker images, deploy them on the same virtual machine,
Mm-hmm.
and let them run for some time just to make sure that there is nothing to be tuned, because when you are running an application natively in a virtual machine, and when
Yeah,
you are running
it's
Docker,
never super easy, right?
yeah, it's never super easy, and sometimes you have to do some kind of tuning. You may have to do some tuning at the application layer, at the network layer, and that is the only difference that I see. So like you should convert them into the Docker images, and like let it run for some time, like do some tests, let it bake in sock, and once you have some confidence that okay, you are not seeing any problem, then you can like start adapting Kubernetes. So ultimately Kubernetes uses Docker, right? Docker images can be deployed in the pods. So after that then, then it becomes pretty easy, because the hardest part is to like convert application from natively installed into the VM into the Docker images. Like that is the hardest part, I think. And after that, like it's all about like bringing them into the Kubernetes space. So like putting the Docker Compose file inside the pods, and taking things forward from there. So
Hmm.
initially you should not go with stateful sets, because you don't know like what kind of impacts it may make, and each and every application has each and every application is unique, so like technically if you see like everyone is using free switch, but still free switch may behave differently depending on the applications that you are using, and the kind of modules that you are using, etc. So you can start with non-stateful Kubernetes cluster. Just orchestrate the Docker images with the help of Kubernetes APIs, and from there go to stateful sets. So step one, like convert it into Docker
The
image.
Docker.
Step two, tune it to make sure there is no performance hits issues with the Docker images. And after that, like implement Kubernetes cluster in non-stateful mode, and then stateful sets if the application supports it. Like especially if it free switch, I don't see that it is that solution is suitable right now. Maybe in future, I'm just discovering. I don't know.
Mm-hmm. Well, in
Or,
FreeSwitch in general, what I recommend people doing is using either my favorite is mod XML curl, so you can
Mhm.
serve a configuration from a web server. So I will my goal when I build a FreeSwitch application is keeping the FreeSwitch servers as stateless as possible.
Yeah.
The FreeSwitch server just exists there. When a call comes in, it will ask a web server. The web server tells it what to do. That's super easy to scale because web servers can be scaled indefinitely, not a problem. And if you need more FreeSwitch servers, just throw them in the mix, have a front end load balancing, and that's all you need. So in this particular case, you probably won't need stateful. Well, I can see how a web app, databases, the kind of stuff, stateful apps are more important because yeah, you have data that is sold with volumes, but also being stateful can be helpful. Yeah,
to wrap.
that's super interesting, and I'll it's something I want to spend time on too. Well, the second thing, which is actually very interesting, we don't speak. We've featured some Kubernetes talk in the past, but I'm very interested about your usage of Kafka and Rabbit and event and other queues, because people really, I feel like there is a misunderstanding about what those things actually are. So, from an expert, like, how did you come to use them, and what are they solving in your infrastructure? Because those are the least. I will say they are the best kept secret in large scale application development. Not many people do work use, and I don't know why. So, how did you get there, and what did they solve in your infra?
Right. So, like initially, like I said, that when we were designing a system, mostly we would try to defeat the performance issues with hardware. So
Hmm.
mostly we would keep on adding more and more servers horizontally, or we vertically scale it. But I think the game is changing now, and usually what we used to use, something that you said, like we would use XML curl. So it would like post the request to a web server, it would return the dial plan, and that is processed. Also for the CDRs, we would also using XML call CDR. So
Hmm.
which would do the same thing at the when the call hangs up, it would just push the CDR to the web server. So only problem was that whenever we are having traffic, when traffic is bursting, or like let's say that suddenly we got lot of users onboarded, thanks to the efforts of marketing and sales. Like we have a
Hmm.
lot of inflow of the users, and the system is not able to keep up with that.
Oh wow,
So
yeah.
yes, adding the hardware is obviously good option, but a system has to be elastic, so it should be able to like expand and then shrink as per the requirement. So that's where I learned about the message brokers, so RabbitMQ and Kafka. So basically, what do they do is that it can serialize any kind of data flow. So let's say that if you are posting 1,000 CDRs, called detail
Hmm.
records, at the same time, and web server also has its limitations. Like web server cannot insert 1,000 records per second. It is more
Oh
actually, but just for the example, let's say.
yeah, sure.
So in that case, sometimes what would happen that the database would get impacted, or web server would stop responding. So what RabbitMQ or Kafka can do, that it can consume all the 1,000, or like tens of thousands of the messages at the same time, and it will serialize it, and it will like send them to the web server, or to the database, depending on your architecture, in a serialized manner, with the defined rate. So in worst case scenario, let's say that if you have so much traffic, and there are a lot of people using your system, and if you don't have enough resources on the web and on the database server, like RabbitMQ or Kafka can do the job of like kind of uh, a kind of cushion, that it will like take everything from there, and it will like let the data flow slowly through the database. So even though if you have less resources on your web server or on the database server, it will be able to manage the they call the processing of all the CDRs. And another thing, like from the free switch, or from the Camilio, or from the OpenShift's perspective, like we used to use event socket layer,
Hmm.
and it is actually great. Like it helps you to remotely control the calls from the external application. And I know that FreeSwitch has its own like queuing mechanism internally. So
Yeah.
whenever you send any command, like it would queue it. But again, like it is native to FreeSwitch, and sometimes if there is lot of commands or the events which are sent to the FreeSwitch may not be able to process them all together at the same time. And sometimes I also observed that the FreeSwitch native queue would get overloaded, due to which like it would stop processing any more calls, and it would kind of like stop responding. It would still
Hmm.
process the existing calls, or whatever it is doing, but anything new which comes in, it is simply not processed, and all of those commands or all of those events are getting dropped. And later on, I actually discovered that FreeSwitch has very good module, Mode MQP, and
Yeah,
Camilio has Kazoo, which supports MQP protocol, and OpenShips also has RabbitMQ module. So actually, you can leverage all those modules to consume the commands, consume the events from the external application. So again, like it is like two-way. You are trying to serialize string and you are trying to control the data flow so that either application they don't get overwhelmed due to the other application, and that's how you actually make your system elastic, because all the pressure, all the additional traffic is actually consumed by the RabbitMQ or Kafka, whatever you prefer, and that actually simplifies the implementation on the application side. And if application is not able to keep up with the kind of traffic that it is getting, it will have some chance to like still stay alive and just don't get blown out. So that's the story behind that. Like initially we used to struggle, and now with this, like life is a lot simpler. And I think Kafka and RabbitMQ, they are kind of lifeline for microservice architecture. Like still I'm not there yet, but I think a lot of people are already using that as a kind of data bus to exchange
yeah.
information across various microservices. So in
You
VoIP
see,
also, I think it will be adapted in future.
I feel like it works very well in what in the general discussion that we're having because as a developer, I mean, before I joined SignalWire, I did consulting for a long time, and the best projects were using Redis as the message bus of sorts, right? Which you can also do that. It's a
Yeah,
little bit less. It's a little bit well suited. Like Rabbit as more is built for that, so it's better. But I think what you're addressing here and what's really a lifesaver is that you don't have to build applications around, for example, there's a lot, you see a lot of prototypes built around HTTP calls back and forth. So your
yeah,
FreeSwitch server asks the web server then has to send a command to FreeSwitch, adds another HTTP call. Then you have the microservice that's handling, I don't know, payments. So you are getting billed for a minute of calls. So whatever is processing your CDRs is making another HTTP request to that billing thing, and the billing thing is calling the web app to tell you that you've spent $1, and all of those, any of those can break down. HTTP is not it's hard to retry, probably the best word. Like if something doesn't get processed correctly, that request is sort of gone. There's, I mean, of
yeah,
course you can architecture so it will, you can try again, you can have your application know that the request failed and it will try again in an, I don't know, in an hour or whatever. But it's all very complicated, yet I see that happening a lot. The main
yeah,
architectures that I see is the main architectures that I see are really built around that. It's
right.
probably wrong, almost wrong. Yeah.
Then also, like one more feature of these message brokers that I would like to highlight is like fault tolerance. Like let's say that if there was any message or an event which was not consumed at all, there is a mechanism to like reinsert them so that application does not have to worry about retrying. Like RabbitMQ or message or Kafka will just reinsert it into the queue and it will be offered again to the various applications. And if it fails multiple times,
Mm.
it can be sent out to a complete different. They call it dead letter queue. So dead letter queue is a queue which you should look for the events that were never processed by the application. So that actually simplifies the implementation
Mm.
on the application side very much, because like, and also like it really, like from my experience, like it has reduced a lot of complexity on the application side, and like keep it as a real microservice. People call it is a microservice, but usually it is doing a lot of things.
Hmm.
And I think RabbitMQ and Kafka like enables us to like actually like let a particular service to do just one thing at a time, and that's where it is like really helpful to me.
Yeah, this ties back into the Kubernetes discussion. If you have this kind of tools in your array of tools you use when you develop an application, it's even the initial design process is different because you don't you start thinking in terms of well, I don't have to think about a message bus, it already exists, I'll just use Kafka because I'm more I know more about Kafka than Rabbit, to be fair. So I will probably use Kafka for pretty much anything, even if Rabbit was slightly better suited. Kind of like if you know Kubernetes, if you're gonna want flavor, like if you're used to K3s, you're probably gonna try and make K3s work, even if the full distribution will solve one problem more, right? So
Yeah,
it's a case of good is better than best if good takes shorter time and it works the same. So it's but you can instead, yeah. If you, I'm thinking about the application we discussed, the fictional application we discussed. Take this FreeSwitch app that's ran by a web server that serves the dial plan and has commands to dial out, etc. You will spend a lot of time just figuring out those HTTP requests.
yeah,
Like have it, well, it's just there, it's use the correct module and just pipe the events into Kafka, someone will pick them up and eventually execute them,
exactly.
and then you don't have to worry about that, so you're working on something else. Next thing is, I know I will have to scale this a lot, so this product is promising, so I need tens of FreeSwitch servers. Kubernetes
Mhm.
just allows me to say, well, you have three now, you want four, just
Yeah,
literally tell me you want 40, here's 40. You just pay a higher AWS bill, and that's it.
yeah,
And then you don't have to worry about that either. So what you're doing is you're really giving your customers, and for example, for Ecosmob, which is a consulting firm at the end, you're giving customers the better value because you're not making your customers pay for hours that are not being spent on solving their problem. This is a
so,
very important marketing tool that we as developers and suppliers should show customers. Like I'm making you pay for work that's helping you, not for me installing servers, which you probably don't
exactly.
care about. Like
Yeah,
it's very important.
yeah, right, right. And like, if you want to survive, you have to do that. Like, that's the future, you know. Like,
Yeah, it
otherwise,
is.
they will not
It
trust
does
you.
enable things you cannot do otherwise. Like we haven't gone into, because we don't do that much that area, and I don't either. But like IoT stuff and the future where you have a million sensors in a house sending data and being processed. Without that kind of technology, both containers and mm, door queues, and I will add 5G and all, everything is related to 5G and the edge, it's simply not possible. Like you will, nobody has a home network that can stand that kind of traffic.
Yeah, right, right. Yeah, it's scary. Like, you are not using it.
Yeah, it's incredible. There's a lot there. Well, again, use Kubernetes, go learn Kafka, go learn RabbitMQ. If you have any questions, reach out to Sagar. He'll be happy to help and introduce you to Ecosmob and their wonderful array of services. We've worked together for a while now, and thank you for. I mean, we've always had a great experience. So,
Yeah, say
looking
likewise.
forward to. And next week it's ClueCon, the actual conference in Chicago, starting on Monday up to Friday, and I'll be there. A few other people will be there. I don't know if you'll be joining, but I think someone from Ecosmob is, and we'll meet you there. If anybody from the audience wants to join ClueCon, there's still time. You have to arrange it a little bit quicker because it's starting on Monday, but it's in Chicago. So if you're close there, just come visit. Its website is glucon.com, and there's a lot of interesting stuff going on. So we'll see you there. And thank you, Sagar.
My pleasure, sir. It was
And
good.
well, we'll meet again soon. I guess that this will become a recurring appointment. So
Yeah,
I'm super
sure. So
happy.
it's every week, like, right? So I will catch you maybe after 4 to 5 weeks.
Perfect. So,
Till then,
and thank you, Sagar, for joining us, Senior Project Manager at Ecosmob. And for the rest of the audience, I'll see you next week, which will be live from ClueCon. Goodbye.
bye.